Hey everybody. First of all, happy weekend to you. Given the vast number of kids who missed number 9 on yesterday's quiz, I'm making this video to review substitution. I'd like for you to watch this at least 2 times over the weekend and to bring the question at the very bottom of this page to class on Monday so that we can go over it. As I've written here, it says, in order to successfully answer a system of equations question, you first have to examine the system by looking at the coefficients of each term and then comparing them to each other. You can decide if substitution or elimination will be easier to use when determining the solution. Now, if you have forgotten what coefficients are, they are the numbers that are in front of the variable. So in the first one, we have 4, and then we have 9, and then the one underneath it, we have -4, and we also have -7. Now, even though this right here is a subtraction symbol, remember when we first explored the integers unit earlier this year, that also means negative, as well as this positive symbol up here means that 9 is positive. That is super important to remember. Otherwise, none of this will make sense. Remember that it means both. When you use substitution, you can you rearrange an equation much like in slope-intercept form and then plug that into one of the variables. I've done that on the left side of this illustration. So I'm going to zoom in so that you can see exactly what I'm talking about. So in this question, 4x plus 9y equals -19 and -4x minus 7y equals 13. So to substitute, what I'm going to do is rearrange one of the equations so that one variable is on one side. In this example, I chose x to be on the same side. It would work the same way when you rearrange it for slope-intercept, except this time I chose a different variable. So when I did that, I took the bottom one, and I could have used the top, but I chose the bottom, and it says -4x equals 7y plus 13. It became positive because this moved over to the other side of equal. Well, to get x by itself, we have to divide everything by -4, which leads me here to x equals -7 fourths y minus 13 fourths. Anytime you use substitution, in my opinion, and you end up with fractions, especially if the slope and the y-intercept, or in this instance, the x-intercept, are in fraction form, my personal opinion is that elimination is simpler to use. That doesn't mean that you couldn't use substitution. It's a personal preference that you choose. What I've done on the right-hand side is shown you how elimination would work in this instance. Now, the way that this question is written, I can already eliminate the x variable without doing anything because up here it's positive 4x and down here it's negative 4x. So when I put these two together here and then eliminate the x variable, that leaves me with 2y equals -6 because 9 minus 7 is 2 and -19 plus 13 is -6. I then divide each side by 2. It gives me y is equal to -3. If y is equal to -3, I then plug that in to the variable where the y is. That's what's up here in this top part. I could have chosen to use it in the bottom equation. You're going to get the same answer no matter what you do. So then I have 4x plus 9 times -3. That -3 came from here. Is equal to -19. That becomes 4x minus 27 equals -19. I add 27 to both sides, leaving me with 4x equals 8. I divide 8 by 4, and I get to x equals 2. So the solution to this is 2, -3. If you were to graph these on Desmos, the intersecting point would be at that spot, which means it has one solution. Remember that if I rearrange these and my slopes are the same and my y-intercepts are the same, that means that the system has infinite solutions. Conversely, if the slopes are identical but the y-intercepts are different, that means that I have no solutions for this system. Since working with integers usually is quicker, and since elimination in this instance is basically already set up, I'm choosing to use it to find the solution to the system, which I just had explained. In number 2's question, I have negative 2x minus 9y equals negative 25, and negative 4x minus 9y equals negative 23. On the left-hand side, I decided to put it in slope-intercept form and because I'm rearranging it in terms of y. To do that, I then wrote, first of all, this top line is just the first part, rewriting the equation. The second part is negative 9y equals 2x minus 25. I then divide all the terms by negative 9. That gives me negative 2 ninths x plus 25 ninths because two negatives divided together equals positive. Again, my y-intercept here is a fraction and my slope is a fraction, so I'm going to choose elimination. And in looking at the original question, if I multiply this top equation here by negative 2, that would then change these terms like I have written here. So I rewrote the top equation from here to here, and I wrote negative 2. Now when I do that, that applies to the whole thing. So this then became 4x plus 18y equals 50. I then rewrote the negative 4x minus 9y equals negative 23 underneath it. The x's canceled each other out. 18 minus 9 is 9. 50 minus 23 is 27. I then divided 27 by 9 and I got y equals 3. I then substituted that here. In this instance, I again used the top equation. I then substituted 3 beside the 9. That becomes negative 2x minus 27 equals negative 25. I add 27 to each side. That gets me to negative 2x equals 2, which then becomes x equals negative 1. To successfully use elimination, think of something you can multiply the entire equation by to eliminate one of the variables. In this one, if I multiply the top equation by negative 2, like I explained, that will create a new equation where the first term is positive 4x. I can then eliminate the x variable. Here's the next question. I've got 5x plus y equals 9 and 10x minus 7y equals negative 18. This is very much like question 2. I'm going to multiply the top equation by negative 2 again to make the x variables cancel each other out. I did that here, and I got to negative 10x minus 2y equals negative 18. And then this equation, the second one, I just rewrote it. 10x minus 7y equals negative 18. That got me to negative 9y equals negative 36, and negative 36 divided by negative 9 equals 4. I then substituted that value over here. 5x plus 4 equals 9. I would subtract 4, getting 5x equals 5, x equals 1. Over here, I use substitution. In the top part, I rearranged this equation to y equals, which got me to negative 5x plus 9. I then substituted that here. I rewrote my second equation here, and instead of writing y, I wrote negative 5x plus 9. I then distributed negative 7 to both terms inside the parentheses, and I got to 10x plus 35x minus 63 equals negative 18. 10 plus 35 is 45x. I add 63 to both sides. That got me to 45x equals 45, and that makes x equals 1. And the last question, in this example, since the y term in the first equation doesn't have a coefficient, both substitution and elimination should be equally easy. I've shown both methods above here to let you see how each method works. My question is negative 7x plus y equals negative 19, and negative 2x plus 3y equals negative 19. Over here is elimination. Over here is substitution. I'd like for you to walk through and look at this on both sides and try to follow the logic. I'm not going to explain it through because I want you to write these out and see if you can follow along with what's written here to do it yourself. Once you've done that, I want you to go down to the bottom and answer question 5, which is a little bit easier. This is how I decide which method to use. If the question has an x variable or a y variable that does not have a coefficient, I usually use substitution. If all of the x and y variables have coefficients, I usually use elimination. However, you decide what is better. Please watch this at least twice. Work out number 4 both ways on paper. If you need to just copy down what I've written here, that's fine. Because even by copying it, you should be able to translate why what I'm doing is working. You can also download the app if you haven't done so, Photomath, which is a free app. It actually, you take a picture of the questions and it solves it for you. Their explanations may not match mine, but that doesn't mean that it's not right. I don't mind you using that program to check your work. Uh, you can't obviously use it on an assessment in the classroom, but for checking work or if you get confused, I think it's a completely fine tool to use. Thank you.